I'm Joe, and I'm here with Shawn, one of our core devs, and we're going to talk about social recovery and the palette that comes with Substrate. So let's get started. Like, what is social recovery?
Yeah, so this social recovery palette is a way for people who use a Substrate blockchain to be able to recover access to their account if they lose access somehow. So normally this would probably be like losing your private key or losing your seed. But I guess Substrate doesn't really assume necessarily that you have to use public key cryptography to access accounts. You probably can do other methods, and no matter kind of how you set up your system to access your account, recovery actually has the ability to give you back access if you were to lose that access.
Yeah, and so we talked a little bit about this as an intro in our last video. Mm-hmm. We'll put the link in the description. But all of the signature verification happens outside of the runtime, and like the pallets just get this origin. And so we're going to use that concept here. So we don't really have time to go like a deep dive into it. But if you're confused, go back and watch our first video.
For sure.
So yeah, let's get into recovery, where you actually lose your private key and you can still recover your account and send funds from it.
Yeah, so I think I'll use some like keywords here. So we call this a M of N social recovery tool. And what this basically means is that we are able to recover your device through social means, but through other people basically saying, this person has lost their account. We trust that this person was the person who lost the account, and we can give access to a new person, or I guess a new account, to have access to the old account. Ideally, this person in the whole situation is just you, but you have one account and you lost it, and now you get another account, and people can help basically say, we're going to tie your new account to your old account.
Yeah, and so what do you have to do first to get started? So like in order to, you can't just recover your account if you lose your private key. You have to do some stuff ahead of time. So what is that? What do you have to do to get ready?
Yeah, so the whole process is actually quite simple to walk down. And we can actually do that just by walking down the different functions in our declare module. So the first thing you need to do is with your original account, the one that you want to recover, you need to, while you still have access to it, of course, create a recovery process. And creating a recovery process is pretty simple. It's basically just setting up a configuration. In the create recovery configuration, you'll see there's just three options here. There's a list of friends. So this is a vector of accounts that you trust to be basically the gatekeepers of your account. You have a threshold, which is some subset of the number of friends you pick, which you say must say like yes or approve your recovery process for you to actually get access to it. So let's say you pick like 5 friends and you say you need 3 of them to say yes. And then a delay period. And this is actually a very critical piece that maybe we'll talk about a little bit later. But the delay period basically says how long from the beginning of a new recovery process do we have to wait until the account can actually be recovered. And this is an important tool to prevent malicious users from getting access to your account through maliciously targeting your friends and having them tricking them into saying yes and stuff.
Yeah, so this is mostly to prevent attacks here. So I think we'll get into that at the end.
Yeah, exactly.
So let's go through what this recovery structure looks like and then how we actually start recovering.
Yeah, so one important piece about runtime development and any kind of these processes is that we need to take deposits when users put data on the blockchain. So actually even better than putting a deposit would actually be putting some rent on some storage. So if you know there's a kind of a classic problem that's happening in the Ethereum smart contract world where basically there's so much storage being used on Ethereum, you only pay one fee up front when you make that transaction. And once you pay that fee, it's just there forever. So if the longer your storage is on the blockchain, the less it costs like per day for you to put it on there, right?
Right.
And this is kind of not something that you can have forever because in the smart contract world, anyone can create a smart contract. That smart contract can support any type of storage item, and it just doesn't scale in the long term. Substrate in their contracts palette actually solves this problem with storage rent. At the runtime level, we don't actually quite have storage rent yet. I think it's something that we might be thinking about in the future. But for now, what we do assume is that if a user is ever talking to one of our pallets and is going to store some information, for example, a configuration for recovery, we want to make sure to store a deposit for them. So in addition to having these inputs, and we do some basic checks to say, okay, are the inputs sane? What we also do is we take a deposit from your account. We basically reserve a deposit, which says we're going to store some funds. You do not have access to these funds as long as you have a configuration. If you remove your configuration, we give it back to you. But as long as you want your account to be recoverable, we're going to hold some funds from you to basically say, okay, this is going to this is going to take into account whatever storage you're holding on the blockchain, right?
Yeah, and this deposit varies based on what?
It varies based on the number of friends you pick. Also, in general, it can be completely configured. So you see here, there's two configuration options here. Basically, one is like the base deposit fee, and the other one is the deposit fee based on the number of friends you select. So you, as a runtime person who wants to use this pallet, runtime engineer wants to use this pallet, you can actually configure exactly what these deposits should be for your blockchain. But know that in general, that we expect the more friends you store, the longer this VEC that we store is of the friends you have, and therefore we want to charge a little bit more per user.
Right, and then so you can see here this recovery config is going to create this struct, and it's just this deposit and then the other inputs, so your delay, your friends, and the threshold.
Yeah. I think one thing that's also important to say, of course, each user may have a different amount deposited. Based off of how many friends they have, right? We could retroactively calculate that, but I think in general it's kind of a best practice to store this deposit information along with the recovery configuration. One, this storage item doesn't really cost anything, but if for whatever reason, I can think of a million random scenarios where in some future we update the configuration where the deposit amount is different, and then there were some users who did it before, and then we reserve some money, and then later we change it. Keeping track of how much we've reserved from the user is kind of an important detail to have, that later when we want to unreserve the deposit, we can unreserve the correct amount, no matter how kind of our runtime changes. So it may seem kind of redundant to store this item, but I think it's a kind of best practice to do so.
Yeah, sure.
Yeah.
So you create this storage item, and then let's say you lose your account. How do you go about recovering it?
Yeah, so the next step of the process is to lose your account. I would recommend not following that step.
Yeah.
But if for whatever reason you lost your account, no need to fear. You have a recovery process set up. You need to actually start it. So the very next thing you need to do is basically initiate a recovery. And so I want to be transparent here and say that this process, this entire module, no one can actually recover your private key. It's not possible to go have a process where we're going to give you back your private key kind of in this nondescript way. What we do is basically give you back access to the account. And we do that by basically granting another account access to make calls on behalf of another account. So what you need to do to initiate a recovery process is 1, create a new account, and 2, basically buy some tokens or funds so that the user can pay for the transactions that follow, and also pay for the recovery deposit. So similar to the deposit needed to store the data, we also take a deposit for a user who wants to start a recovery process.
Right.
Yeah. And so let's take a look at this real quick. So basically, this can be called by any user. This is completely permissionless. So anyone, whether it be you or someone malicious, could initiate a recovery process on your account. Again, we take care of that with another with the delay factor. But anyone can initiate a recovery process. We basically verify that the account that you want to recover is recoverable, and we take the deposit needed to start the recovery process. And then we basically put in the storage, hey, there is some kind of active recovery process happening.
Yeah.
You can see here that we store basically when the process was started. Again, how much money we've deposited from the user, we've taken from the user, and the list of friends that have approved the recovery process. And right now it starts empty.
Yeah, because you're just initiating it, so nobody's done anything.
Exactly.
And so now this storage item goes in, this active recoveries.
Now users can actually go and help you recover your account.
Yeah, so now you need to call your friends.
Exactly. So off-chain, maybe on-chain if you have some fancy pallets there, but probably off-chain, you go call them and say, hey, I messed up, I lost my account. I made you as one of my friends. Can you please call this pallet with this function, with these details, and help me recover my account?
Yeah.
And so your friends would call this voucher recovery function. And this has two inputs. One is the account, which is lost, and the other one is the account that you believe is correct. And so when you're contacting user, you should tell them, hey, I want to recover my old account, which is this one, and I am this account, right?
Right.
Of course. And again, there could be multiple recovery processes in parallel. Again, imagine a malicious user is attacking you. You want to make sure that the person is approving the correct recovery process. So these details are important. But basically what we do here is we just check, hey, is there an active recovery for this account? Are they part of the friends list? And if they are, have they already said yes or no to the recovery process? Have they already vouched for that recovery? If they have already vouched, obviously we're not going to put 2 vouchers in there. That could break the system. But if they haven't, we insert in this new recovery. You can see one of the things we do here is we actually use a vector, and we also do things with a binary search. So basically, we want to very quickly find if a user is part of this vector. And if we do an unsorted list, it would have complexity of what, like n log n.
I don't remember.
Yeah, I think it was like n log n it would just to search the entire thing would be just n, right? You ideally have to look at every single item in the list to be able to find if that account was there.
Yeah, so the expected value would be half the list.
Yeah, so if you're going and you do a sorted list, the search time goes to log n, right? Because you can basically do a binary search and find the element more quickly.
Right.
And so, it's zero cost in this situation to basically, since we started with an empty list, that we just insert every item sorted, and then when we do searches, we also can search it sorted.
Yeah.
And so this is one of those things that if you're using vectors, if it's possible, always use a sorted list.
Yeah.
Makes sense? Okay. So you have all the users, they vouch. You need to have, again, at least threshold number of them say yes.
Yeah, so now you're kind of like waiting because it's not just, this vouch isn't just going to be called once. Like you need to find your threshold number of friends.
Exactly.
Like in the example, 3 people need to call vouch.
Exactly.
And then so once 3 people have called vouch, then what happens?
Yeah, so maybe in one world you'll be able to just say, hey, I got my account recovered. But this is not necessarily secure. Again, I think one of the things we know in the security world is that the number one fault of people maliciously getting access to your account is actually not through software problems, but through social problems. That, someone calls their friend saying, hey, Shawn died, and, the parents are trying, I'm a lawyer for the parents, I'm trying to recover the account. Please, approve this recovery process, blah, blah, blah. And you being a very nice and willing friend and very sad that your friend passed away are going to just say yes. And this would allow a malicious user to basically abuse the system. So what we include is this delay period. And this delay period is this mechanism basically where even after you've gotten all of your approvals, the M of N approvals, you still need to wait at least some number of blocks that you define before the account can actually be recovered.
Right.
Yeah.
So in that case, like say you set it to, I don't know however many blocks is equal to 1 month.
Yeah, 1 month, exactly.
Then you just need to check your account every month and check if a recovery process has been initiated. Exactly.
So if you have access to your account, all you need to do is once a month check, is someone else trying to recover my account? If they are, what you can do actually, and we'll skip this claim, so let's just go the malicious path. If there is someone malicious trying to recover your account and you detected it, you just call close recovery. And what close recovery assumes is, hey, this is being called by the account that is trying to be recovered. Obviously, if you can call with that account, you have access to it, so it's not actually lost. And what you do is you just take the reserve funds from that user. So you see here we call repatriate reserve, which basically takes from one person's reserved and puts it into my free balance. So if Joe is malicious and trying to attack my account and trying to start a recovery process, even if he gets all my friends to say yes, Joe has to wait 1 month, and I can just check once a month, say, oh wow, Joe is trying to steal my account, take his funds from me, and wow, I just got paid for this guy trying to attack my account.
Yeah.
It's like a honeypot.
Right.
Yeah. And so this is that mechanism for being able to basically keep your account safe. And so the longer the delay period you pick, obviously the longer you have to wait in a successful recovery attempt, but also the less often you need to check your account.
Right.
And it's up to you to kind of determine what is the right number.
Yeah. So if we say this was an honest attempt and that you went through this recovery process and then you wait through the end of this period, then what do you do to actually recover the account?
Yeah, so then what you do is go back up 1 level and call this claim recovery function. And claim recovery function is very simple as well. It basically checks, are all the parameters met, right? So we get your recovery configuration, we get the active recovery process, and we say, okay, are the number of friends in the active recovery process that have been approved meet your threshold? And that's what this one here is, this threshold check. And also, is the current block time, greater than what we'd expect for the threshold? So we check the initial day of the active recovery being created plus the delay period, and that's when we start checking, is the block number past that limit?
Right.
And if all of this happens, we do something really innocuous. All we do is insert one storage item. We insert into recovered the account that is trying to be recovered and who you are, the person who's allowed to recover that account.
Yeah, so now you can actually sign messages on behalf of that account.
Yeah, and so what we can do is actually we can jump up, but this what I'm trying to say here real quick is that every account can only have basically one user who can access it at any time. And so if you have this storage item set, you can go all the way back to the top, and there's this function called as recovered. And as recovered basically checks the storage item is there and allows one user to make a call on behalf of another user. Again, we talked about this in the last video. It has to do with a lot of cool stuff with origin, but basically, you can make a call on behalf of your lost account using another account. We haven't given you back your private key, but we've given you all the access your other account has.
Yeah, so if you lose your account A and then you create a new account B and you recover A with B, you can actually send a transaction from B using this as recovered and make the other pallets in your runtime think that this actually came from A.
Exactly. And this is much more powerful than other recovery mechanisms which kind of exist today in the smart contract world or in other places, because in Substrate, we can actually control who your pallet thinks you are. In every other kind of system, you'd have to build in logic for kind of every single interface you're interacting with would have to have some logic on how recovery would work. But here, you can just have I am this person, and this allows you to put on that mask, or allows you to basically trick the other pallets that I am that person. Yeah. And that's kind of the magic here, that one pallet makes all of your system recoverable.
Right. And yeah, if you want to learn more about this origin stuff, you should definitely go check out this other video because it's a really powerful feature of Substrate.
Yeah. I think one or two more things we want to touch on before we end this thing. One thing I want to mention real quick is set recovered. So we also added a special functionality in the chain to basically allow governance to also automatically skip through the whole process. So if for whatever reason, your friend's recovery account didn't get recovered, you didn't put a recovery configuration on your account, or your friends aren't supporting you or whatever, if you can convince whatever body has access to the root origin to give you access back to your account, we allowed that to happen. I assume that this process would be much more difficult than any other recovery process here. So you should assume that this root access should be much harder to gain access to than basically going through a correct malicious process.
Yeah.
But it's something that's there that even if you haven't set up a recovery configuration, if you know the creator of the blockchain or you know the right governance people, you can make it happen. Yeah.
Yeah. So if your cruise ship sinks and all of your friends are on it, then maybe you can convince governance that that you actually need people to vote to let you do this.
Yeah, there's no promises on that this function will ever actually work for your specific situation. But again, if whoever has access to root, we assume this is the highest privilege level. That highest privilege level should be able to give you access to your account.
Yeah.
And the last thing in terms of this story, after you close the recovery process, this was getting back your reserve deposit, you can actually remove the recovery altogether. And so this is kind of a process where, let's say you're finished cleaning up your old account. You can actually remove the recovery process. You get back your final reserved funds for actually having a recovery process, and this allows you to transfer the last piece of balance out of your old account into your new account. And then we have some automatic magic at the bottom. We have this trait called on-reap account. On-reap account gets triggered whenever an account has absolutely zero funds. That means no free balance, no reserve balance. And when that happens, basically we assume the account is totally dead. What we do is we automatically clean up the recovered process here. So as long as your old account has some funds in it and you have gone through the successful recovery process, you will always have access to your account. But as soon as you get rid of everything from it, it automatically cleans it up, and now this is an account back in the wild that, just has nothing, no information, nothing on it.
No state at all. It's all clean.
Exactly. And so, in general, as a runtime developer, you can create this. You can add this trigger to your pallet to basically clean up or do some cleanup on your blockchain or your pallet, so that it removes items about users who don't matter anymore. And so, after this is triggered, no user will have any information about their pallet that is not that's not being active or in process of being recovered or anything like that.
Yeah. Anything else to add before wrapping
up? No, that's pretty much it. It's a pretty interesting little pallet. It's definitely, I think, very useful. It's a thing that I wanted to build for my parents to be able to use the blockchain. And now that it exists, I'm much more happy to be able to have them go and actually use blockchains without, feeling scared that they might lose their keys.
Yeah. All right. It's great. Thanks, Shawn.
Thanks so much. All right. See ya.